Section 6.3 is solving systems using elimination. I can solve systems by adding or subtracting to eliminate a variable. Big ideas here. Systems of equations can be solved in more than one way. We've done graphing, we've done substitution, and today we're going to start with elimination. Some equations are written in a way that makes eliminating a variable a good method to use. In example 1 here, we're solving a system by adding equations. When we look here, guys, it doesn't look super easy to graph. It doesn't look super easy to solve for a variable. None of them are isolated already or have 1 as their coefficient. So we're going to try and use elimination here. And what elimination does is it lets us add our equations together because we know that they're the same on each side. Negative 9 is what 6x minus 5y equals. So we're adding the same thing to both sides of our equation. It just looks a little different. And when I do that here, positive 5y plus negative 5y just gives me 0y's. So 2x plus 6x gives me 8x. 17 plus negative 19 gives me 8. We can solve for our x by dividing, and I get x equals 1. And just like in our last few sections, when we're solving systems, we're not done once we have one variable. We have to find both. So I can take that value and plug it in to one of my equations. Doesn't matter, it just has to have both x and y in it. So 2, we said that x is 1, and the rest of our equation stays exactly the same. I get 2 plus 5y equals 17. Subtract 2 to get our y term by itself, and then divide by 5 to get y completely isolated. And 1, 3 is our ordered pair. Remember, it's always x and then y. If we plug those back in to double check, 2 times 1 plus 5 times 3, 17. Just plugged in my x and my y values. 2 plus 15 is 17. So here, this one checks out. Same thing in my second equation, 6 times 1 minus 5 times 3 equals negative 9. 6 minus 15 is negative 9. So that one checks as well. So to check and see if our answers are right, it's as easy as plugging them back into both equations. They do have to work for both equations though. So if it works for one and not the other, it probably means you solved your first variable wrong. Or did something wrong on your second when you were finding that one. What is the solution of the system of equations here? Using elimination. So, first I'm going to add negative 6y plus 6y gives me 0. 5 plus 3 gives me 8x. And negative 32 plus 48 gives me a positive 16. Again, I'm going to divide to get my x completely by itself. And we get x equals 2. Now that I know that x is 2, I can plug that into one of my other equations. If x is 2, I plug it in for x and solve. It doesn't matter which equation we plug it into, as long as it has both an x and a y. I'm partial to plugging into one of the original equations because I know those equations are right. I know that I didn't accidentally put a negative in the wrong spot or forget one. So, we multiply here to get our equation. Now we subtract to get our variable by itself. And when we do that, guys, remember that the sign in front of a number goes with it. So I have negative 6y equals negative 42. Divide, and we get 7. My final answer here is my ordered pair 2, then 7. And remember, it's always x, then y, not necessarily just the order that we found them in. Here's another one that you can go ahead and pause and give it a try if you'd like. Okay, so if we look here again, not super easy to use substitution, so we're going to use elimination. I can go ahead and add these right away because I know that negative 3x plus 3x equals 0. It doesn't just have to be the y that we eliminate right away. It's anything that's opposites. So because I have opposites, same number, different signs, I can add them up right away to get 0. Now I take negative 3y plus negative 4y and get negative 7y. And I take 9 plus 5 to get 14. To get our y by itself, we divide, and I get negative 2. Now that I know what y is, I can plug that into one of my equations. Doesn't matter which one, as long as it has both variables. Here, remember that when we multiply, we take the sign in front of a number. So we get a positive 6, and we bring down the rest of our equation. Subtract a 6 to move it to the other side, and divide to get our variable by itself. We get a negative 1 for x. So negative 1, negative 2. If we plug it in, here it works. So we are good. If we plug it into both equations, that is what we should get. In example 2 here, we're solving systems using subtraction equations. The theater club sells a total of 101 tickets to its first play. The student ticket costs $1 and an adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So here we are looking for student tickets, which means we're going to have to compare two different types of tickets. We have student tickets and adult tickets. We also have totals here. We have a total of 101 tickets and a total ticket sales of 164. So I have 101 tickets total and $164 total. So the two things that I'm comparing here are number of tickets to cost of tickets. So we talked about that yesterday a little bit. We're going to have one that deals with quantity and one that deals with cost. When we look at this, as far as the quantity goes, the number of tickets, 101 tickets, the kinds of tickets we had were adult tickets and student tickets. And I'm going to use T for that, for student, because my S's and 5s are too close. As far as our cost goes, we're dealing with money here, so we're going to deal with money parts of our numbers. Student ticket costs $1. So to find the total cost, we take price, $1, times the number of tickets, which is T. For adult tickets, they cost $2.50. So we're going to take our cost times the number of adult tickets, A. Now, if I look at this, I'm going to rewrite it just real quick. 101 equals A plus T, and 164 equals 250 A plus 1 times T. We can just write as T if we want, or here we could put ones in front of each of those if we wanted as well. If I look here, I can't just add these up right away. If I took T plus T, I'd get 2T, not 0, and we're looking to get 0. So we need to somehow come up with a way to get opposites. I'm going to change all of these by like a -1. Just multiply it through all of my signs, because I need this T, or one of the T's, to be opposite. Doesn't matter which equation you change, as long as we can get opposites. Now, I have 101 equals A plus T, and -164 equals -2.50A minus T. Remember, we changed that sign all the way through. It's like I multiplied that whole equation by a -1. Now, I have opposites. T plus -T gives me 0. So I can add up both equations. Here I get -63 equals -1.50A. To get A by itself, we're going to divide. And A is going to be 42. Now that I know what my a value is, I can take that and plug it in to find my t value. And we can do that in any equation that has both an a and a t in it. I'm going to use this one, but we could have used this equation, we could have used this one, that is the same, but it would have worked there as well. So 101 equals 42 is in for a plus t, and make sure we plug it into the right variable there. We have the adult tickets, so we have to plug it into the adult tickets. Subtract to get t by itself, and we get 59. So how many student tickets were sold? 59 student tickets. Feel free to pause here and give this one a try. Now, washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? So we're looking for how long, so we're looking for a time for each type of vehicle, which means we're looking at both types. Here I have cars, C, and trucks, T. And we're comparing time. So the 130 minutes is one of my times, and the 190 minutes is the other of my time. For 130 minutes, I have 2 cars, so 2C, and 3 trucks, 3T. For 190 minutes, I have 2 cars and 5 trucks. Once again here with our system, we don't have opposites, but I can get some. I can multiply one of my equations, does not matter, by -1 and change all of my signs so that they are opposites. Now I can go ahead and add, because 2c minus 2c or 2c plus -2c gives me 0. -60 equals -2t. I can get t by itself by dividing. And trucks is going to be 30. How long? We're talking minutes. Now that I know t, I can plug that in to find c into either equation, does not matter. And I plug that in for t, everything else stays exactly the same. Multiplied there, now we're going to subtract to get our c term by itself, and divide to isolate c. And for c, we get 20 minutes. So 20 minutes for cars, 30 minutes for trucks. A real quick recap here over the first half of section 6.3. Systems of equations can be solved in more than one way, and some equations are written in a way that makes eliminating a variable a good method to use. And that's all here for the first half of section 6.3.